Good. Fine. Ready? Good. Today we're going to see a new topic, a new rule again. This is the chain rule. But this is going to be the last topic before the next quiz. Next quiz is going to be next Friday, tomorrow, next Friday. But next week we're going to spend the days practicing all the rules. With a new activity. Except on Wednesday when you have the project. So don't forget the project. Okay. Fine. So what's the chain rule? Before we start with the definition, I want you to remember something. Remember about composite functions? No? Yes. Okay, basically a composite function is when you have a function evaluated with another function. You saw that in math 3, I think. Like the first and second part. But okay. So basically, no, that doesn't matter. You'll remember with examples. The chain rule then is when you have a composite function, if I want to find the derivative, I cannot apply the rules directly. I need to use the chain rule. Well, the chain rule in general is like a general rule for derivatives. In what way? In that, for example, if I have a function that's a composite function, you have a function g instead of a function f. The derivative of that is going to be the derivative of the inner function, g prime, times the derivative of the outer function evaluated with the original g of x. Okay? So it's like find the derivative of each layer of functions, one by another one. Okay? It's as simple as that. But the idea is that when we find the derivative, we need to use the previous rules. Example. Here, y equals to 3x squared plus 5 to the 7th power. In this case, for example, can I rewrite or simplify or expand it? No. Okay. I can expand, but to the 7th power, it's not practical unless you use the Newton's binomial, which is something that you didn't see. Or maybe you have seen in math too, but I don't know. It doesn't matter. What matters here is that if you observe this is going to be a composite function, you have two parts, two components for that. In this case, we see that the 3x squared plus 5, that's the first component, the inner function. But that function is raised to the 7th power, so that will be the outer function. Okay, fine. In this case, if we want to solve this, we cannot do it directly. We're going to decompose the function first and then apply the formula. In what way? Well, let's try to identify which one would be my g of x here. 3x squared plus 5. Okay? And then we have the f of the function, the bigger function. So we're going to call it f, and that f is going to be what? It will be x to the 7th power, but in order to avoid confusing that in the derivatives, we're going to use the previous letter. So it's going to be g to the 7th power. Okay? So putting x to the 7th is fine. Yeah, but to avoid confusion, when I find the derivative, I'm going to use the previous letter instead. That will be easier to work with. Now what? I already decomposed it. Now we're going to find the derivatives of each one of them. So, y prime, the derivative is going to be the derivative of g, derivative of this. 3x squared plus 5 derivative? 6x. 6x. That's what? That's g prime. Times the derivative of g to the 7th. Do it as you normally do the power rule. 7g to the 6th power. That will be the f prime. Okay, that's my derivative, but my final answer has to be in terms of only x. So I need to back substitute g for what it was. So the y prime is going to be 6x times 7. G is 3x squared plus 5 to the 6th power. Okay? That's my derivative in terms of x. Because the g is because the g is this. So I'm having everything in terms of the variable, which is x. And now we simplify. So y prime is going to be 6 times 7. It can be done. It's going to be 42x times this to the 6th power. And that's the answer. Yeah. That's the answer. No, you can leave it indicated as that. So the idea is the chain rule is to avoid expanding all that.
Okay.
It's too long. Not practical. Okay? Questions? Good.
No tengo.
Fine. Next one. Let's say we have ln of sine of the square root of x. Yeah. Let's observe. How many components do I have? 2, 3. I have 3. Why? Because in this case, for example, that square root of x is different than just x. So we consider that as a separate function, a separate component. So we're going to use another letter. Let's use H, G, and N. So the first component, the innermost function, is going to be this one, which is square root of x. The second one, the G, is the next one. Which is going to be sine of H. And F is the last one, the bigger function, which is ln of G. Okay? Do you see what I'm doing?
Yes.
Step a step, layer by layer. Now what? Well, in this case, if you want to, we can rewrite that into x to the 1/2. When the derivative is here. Now the derivative. Y prime. Derivative of x to the 1/2.
1/2 x to the minus 1.
To the minus 1/2. Times. Sine of h, derivative. Cosine. Cosine of h. Times. ln of g, derivative. 1 over g in this case. Yeah. 1 over g. Okay? That's the derivative. Now we start back substituting to what they were. Y prime. In this case would be 1 over half times cosine of h, which was square root of x, times 1 over g, which is sine of h, which is sine of square root of x. Okay, and the derivative. Well, I need to simplify. But the derivative is this.
Profe, ¿hay cuántos puntos contar?
75, perhaps 80, depending on the next steps. Can I simplify this? Yes. Y prime equal to. This one is the same, but here I have cosine of square root of x times 1 divided by sine of square root of x. Is there a formula that simplifies? Cotangent. So it's going to be cotangent of the square root of x over the 2 square root of x. And that's the answer. You cannot cancel this with this one, because this is not a product, this is cotangent of this. So this stays there, and this is the part of this.
Sí, porque coseno se va arriba, el seno es el cotangente.
Cosine over sine, that's cotangent, yes, but you need to maintain the argument. This is called the argument. So you need to maintain it. It's always cotangent of something. So that's the something. Can't cancel it. That's it. Questions?
No.
Yeah, sure?
Yes.
So far, too easy, right? No, because it's cosine times 1 over sine, cosine over sine is cotangent. That's one of the. That we're simplifying. Well, let's say that if you leave it here in the exam, well, it's not complete. Because you have 75, 80%. Perhaps we have 90%. It's not that much of a difference between this and this one. So, good. Let's try to do a summary of the steps.
Separate.
Okay. Think of this as a general procedure. That was the first step, always. No, the very first step. Huh?
Separate.
No, rewrite. Always rewrite and simplify.
Always rewrite.
And simplify. If it's needed, of course. For example, in the first one I need to rewrite, but in the second one I need to rewrite the square root. That's always the first step, always, always. The second step will be to identify and decompose the parts. Propose the form. Third step, after you decompose everything, then you apply the rules. Apply the derivation rules. Apply differentiation rules. After that, then we back substitute. And number 5 will be to simplify and rewrite. That is non-negative, non-fractional exponents. Okay? You may wonder why do I say that it's optional to decompose? Because, well, right now, since you're only learning how to do it, I'm decomposing part by part, but my intention is that later, next week or in 2 weeks, you need to skip this step. You need to try to find the derivative of this directly. Single step. How? Well, you need to write all of this. For example, here, I know that this is for the inner function. Derivative of this, 6x. Derivative of everything, 7 argument to 6 power. In a single step.
In a single step?
You need to try to. Yeah, why? Because in this case, those are easy. 2 parts, 3 parts, maybe 4 parts. But if the function has like 5, 6, or 7, and they could have, you're going to lose a lot of time by decomposing and then back substituting again to what they were. So try to start doing it in a single step and then just simplify it again.
¿Esos derivados se grafican?
No. No. Okay.
Mañana compra pizza.
Fine. Can I erase?
Yes.
Okay. This one?
Sí, la regla primero de es que los pasos.
Yeah. ¿En qué momento? Profe.
0.17 por el principio.
Profe, ¿qué es eso de back substitute? Like here, for example, we have this, and then instead of h, you put what was h. So you back substitute to what they were. If it's g, instead of g, you put what is g, sign off. Where so you, at the end, everything is in terms of x. Okay. So you can put it here also in terms of the variables. Good.
Teacher, in this case, we have
Actually, no.
we have 4, no?
We'll see. Okay. The confusing part about composition is that you can have more than one component, but if you simplify the function, you can lower the number of components. For example, here, this one. This one is a little more complicated, but it's not that much. But something like this could be the exam.
Why?
When you fail, that's why. No, it's easy. Just think a little. Can I simplify this?
Yes.
Yes. You have a square root of that fraction. When you have a square root of a fraction, you can apply the square root to the numerator and the denominator separately. So in this case, for example, the square root of 25, 5, over the square root of this, x squared plus 3x minus 2 to the what? The what?
3.
What? 6?
7.
7 house. Remember, it's the 7 power, that's the numerator. The index is the denominator. Yeah, you already got the 5, so that's okay. But for the denominator, no. Yes or no? Good. Now, from here you could apply the quotient rule if you want to, the one that we did yesterday. But the chain rule allows us to rewrite this. So in this case, for example, I can put the denominator as a numerator. I just need to change what? The exponent. So now you have y equal to 5 times x squared plus 3x minus 2 to the what? Minus 7 halves. Now with the chain rule you can do it. You can solve that.
¿Cuál recomienda usted, profe?
The chain rule.
Yes, más fácil.
Some functions are more complicated if you don't use the chain rule. Okay. Okay. Now we have something simpler. What will be my components here?
We have
G. What will be the innermost function?
x cuadrada plus 3x
Minus 2. All of this. All of this. What will be the F? 5 G to the minus 7 halves. Okay. So I now have just 2 components instead of 3, 4, 5. Okay. You may get confused by, okay, how do I know if I need to choose just the x squared of the entire thing? Or how do I know if it's just the 5 or the 5 everything to the power? Try to make your components so you can apply the basic rule directly. For example, in this case, if I choose 5 g to the minus 7 half, I can apply the derivative for that directly, the power rule. And if I choose this one as my function, I can apply the regular rule.
Yes.
So try to choose your components to be something that you can apply the derivative directly in a single step. Do you get that?
Yes.
If not, with practice. Okay, you need to practice to understand that. Fine. Derivatives then. Y prime. Derivative of g equals 2x plus 3. Okay? Derivative of minus 2, 0. Times 5g to the minus 7 halves. Derivative?
Menos 35 medio.
Y
Minus 9 plus. G minus.
yes? I apply what? I leave the constant, I get the power rule. The coefficient becomes, the exponent becomes the coefficient, multiply them and subtract 1 to the exponent.
Yes.
Good. Now what? Substitute. Y prime equal to 2x plus 3 times minus 35 half. What? What's the G?
X
squared
plus
3x minus 2 to the minus 9 halves. And then I need to rewrite. Y prime equal to minus 35 2x plus 3 over 2 times square root of x squared plus 3x minus 2 to the 9 power.
Oh my god.
That's the answer.
Wow.
I just rewrite everything, I'm rewriting everything, and then I need to put the coefficients at the beginning, the numbers at the beginning. That's the answer. Questions? Yeah.
I get that it's easier using the chain rule, but you could use the quotient rule and then chain rule.
You could, but you still need to use the chain rule for the denominator because you have a function in a function with the power
Chain rule, product rule, chain rule.
at the same time. Yeah, remember that when I do the derivative, it's a single step. Derivatives for everything, applying all necessary rules.
Teacher, why did you eliminate the two
Good. Questions? No? Very good. Fíjate que
Muchas gracias.
Fine. Tomorrow we're going to begin with this activity, but right now I'm going to do some examples together with you, okay? Yeah. For tomorrow we need to finish the 3.2.2, 3.2.3, the product and quotient. This one is due Tuesday. Tuesday. Not Monday, Tuesday. Okay. Fine, ready? Okay. In the first part you have a function to find the derivatives in the chain rule. Which one seems difficult to you? Don't tell me all of them.
5. Number 5. Very difficult.
5 seems to be a very difficult one.
We'll do 5. We'll do 5. But let's try to at least check the other ones to see the components. Okay? For example, number 1, the same thing I did at the beginning. How many components do you have? 2. X squared minus 1 and that to the 4 power. Components. Number 2, how many components?
3.
4. 1. X squared plus 4. The square root of that. The sine of that. The ln of that. So there are 4. No, why?
No se checa toda la...
Yes, it is. That's patient.
This is just the beginning. The teacher will say, oh, my second semester.
Anyway, number 3. How many?
3 components.
Just 2. What?
Ah, sí, tú.
Just 2.
Se pasa hacia arriba, ¿no?
If you rewrite, so you can take 3, I know that, but if you get 2 by reverting that, it will be a lot easier.
The next one is
Number 4?
5.
Just 4. 4.
La X no contaba como una.
Now, okay, you could take the x as one function, but the answer is 1. The derivative is going to be 1, so it's within that. Yeah, so no need to put it. It's just 4. Okay? Number 5. What happens with number 5? How many do you have?
5.
No, actually, no. Actually,
3.
no.
2. 2.
Now, listen. Observe. You have this function plus another function minus another function. Remember, when you have addition and subtraction, there are different functions. So in this case, for example, you have this function with 2 components, this one and that one, plus another different function with 2 components, this one and that one, minus another function with 2 components, this one and that one.
Oh my God.
Creo que voy a morir.
Yeah? Okay. Listen. Remember, there is a rule that says f plus g prime is f prime plus g prime. That's one of the basic rules. There's one difference.
Yes, so we get it right.
It's the derivative of this with chain rule plus derivative of this with chain rule minus derivative of this with chain rule. So step by step. Let's do it.
Let's get it.
Let's do it. Okay.
Let's get it.
Fine. Okay. This one. Let's decompose each part. For this function, I have 2 components. This one and that one. So my g for this function is going to be what? 3x plus 1. And f is going to be e to the g. That's for this. Now for this one, a different function. What's another g? The g for this one.
2x minus 1.
What's the f for this one? Sine of g.
El seno de G.
¿Qué? ¿Qué pedo, papá?
The last one. G. And f.
Coseno de G.
Forget about the minus. Leave it.
Coseno de G.
Coseno de G.
Oye, yo también soy español.
Papá.
Okay. Derivatives for each one. Derivative of 3x plus 1. 3 times e to the g derivative. E to the g. Same. The next part. Plus 2x minus 1 derivative. 2 times sine of g.
Cos of G.
Minus 4x plus 2. 4 times minus sine of g.
Oh my God.
And then I substitute and simplify if I can. 3e to the what? 3x plus 1 plus 2 cosine of 2x minus 1. Minus 4 times minus sine will be plus 4 sine of 4x plus 2. Okay? Just be careful with the letters. I decided to use the same letters. You can use different letters if you want to. A, B, C, D, M, N, whatever. Just maintain that. That's the answer.
Take a selfie.
And that's,
No, you can't.
that's the answer.
That's the answer. Nothing to do here. And you cannot multiply anything. You cannot add anything. That's the answer.
¿Y así nomás quedó?
This one, yes.
Así nomás quedó.
No sé qué es lo más difícil, pues.
Oh, okay.
Así nomás quedó como el pirata.
Creo que era la más difícil.
¿Es tu cuaderno de mate? Wow.
De alemán.
Sí, qué órale, Georgie.
¿Qué es eso?
Mi Jordan de alemán.
¿Journal? ¿Escribe todo el estilo del cine?
Sí.
Puede ser eso.
Tú vas a reprobar, ya me constante de
No sé, pero yo diría que nos vamos a reprobar.
Es una verdad, profe. Oye, sí, eso
Me puedes empezar a llevar de aquí allá.
Lee secreto.
Verdades de
Lee
siempre.
secreto.
But in this particular case, everything you can do.
Lee secreto.
There's something is going to be more.
Verdades son más de siempre.
Good. Okay. Next part. Part B, now the table. Remember? Okay. It's almost the same situation, but with little changes because of the formula. Let's try to do this one. F g of x prime of minus 1. F g of x derivative of minus 1. Okay, in this case, it's better if you apply the formula. See what happens. So if I apply the formula, it's going to be g prime of minus 1 times f prime of g of minus 1. What? Yeah, the first one. The first one. So that's the formula applies, right? Now we're going to start changing, substituting the values while the values are in the table. Tell me, g prime of minus 1. 5 times. But then it says f prime of g of minus 1. So it's going to be f prime of g of minus 1 is what? G of minus 1. Minus 2. So I need to find first the f prime of minus 2. It's not in the same place, it's in another row. F prime of minus 2 now is what? 2. So 5 times 2 equal to 10. The distance a little more confusing perhaps because it is a whole table, not just a single row. It's the whole table. ¿Por qué dos, profe? I repeat. This is the question, this is the formula applied, right? Now, g prime of minus 1. G prime of minus 1, 5. Then it says f prime of g of minus 1. So first, g of minus 1. G of minus 1 is? Minus 2. So you have f prime of minus 2 now. Then we solve this, f prime of minus 2. F prime of minus 2. 2. So now it's 2. 5 times 2, 10. What? No, so now in this one, you need to use the whole table. All the values, not just a single row like the previous ones. What? What? Let's try another one. For example, the third one. It says G of x, derivative of, no, 3. The third one. Okay, again, step by step. Apply the formula. So it's going to be G prime of 3 times G prime of G of 3. That's the formula, chain rule applied. Yeah? Now we start putting the values. G prime of 3 is what?
0 minus 1.
Minus 1 times G prime, I leave it indicated, and then G of 3, 0. But then minus 1 times G prime of 0, 3. G prime of 0 is 3. So now my final answer is going to be negative 3. Get it now?
Yes.
No? What's it now?
Porque a ver, te da uno luego de ver.
Profe, ¿por qué cambia a 3? Porque hay 3
The formula. Derivative of the inner function and derivative of the outer function. That's the formula. The same formula, but with only this.
Profe, hace 2 años no daba usted.
Más complicado.
Que le pregunté bien por si era. Que eso sabía de Siberia y Mexicano. El campeón.
Voy a estar interesante ver eso, la verdad.
Profe,
Fine. Let's try number 2. Well, the second row. And with that we finish. Okay? Fine. Remember, you have this. Apply the formula so you don't get lost with everything. Apply it. Write it down. So it's going to be f prime of minus 2 times g prime of f of minus 2. Right?
Yes.
Yes. So check. F prime of minus 2 is 2. So we put the 2 times g prime of f of minus 2. F of minus 2 is 0.
Aquí viene
5. Y no hay.
Ok. Aquí en la segunda fila, o sea, aquí se parecen 5 en su actividad. Pongan el 0.
Ah, no más.
¿Qué está pasando? Ah, no, sí es cierto.
No le entendía, pero
profe, también hay otra.
Sí, puede que haya errores, los errores me los comentan porque lo pasé el primero porque las cambian.
Ah, sí, en
No,
menos
no puedo.
7.
Me van a PDF y
En menos 7, en menos 2 de 3, lo copiamos a menos 2 de 3. O sea, los copiamos tal cual estén ahí.
Sí, puedes comenzar aquí, por favor.
Vamos a trabajar.
Sí, es que no puedo echar las cosas yo a Tiberio, es que las tienen en su archivo. Para eso la que las tienen, yo no puedo cambiarlas.
¿Cuáles serían los que están más?
No sé, chécale. Era este que y la lavamos.
Esos dos
Mira, mejor. A ver, sí.
Le sale un menos 7. Ese menos 7 tiene que ser menos 2.
Cambien los números como están aquí, por favor. Ah, y otra cosa. En la última hoja debería haber gráficas, pero no las tienen, como que las tienen en blanco. Mejor imprímalas. No, sí, claro que sí. Imprima la actividad de respuestas. Imprima la actividad de respuestas. La actividad de respuestas, imprima la mejor esa. La que vamos a hacer esta mañana. ¿Vale? Por favor, tiene errores. Bien. Imprima la actividad de la respuesta. La actividad de las respuestas ya hecha.